Alrighty, let's take a look at that IntCell class one more time. And we'll take off from where we left off, namely the improved version. But this time we're going to separate the interface from the implementation. So we'll declare this IntCell class in a header file, and then we'll define it in an implementation file that ends with the CPP extension. And then we'll take a look at how we might use that definition in another file that simply makes use of this class. So to begin with, let's take a look at the IntCell declaration. So here we are looking at figure 1-7 from the Weiss textbook. And here what we see is a couple of things. One is on lines 1, 2, and 18, the use of this multiple file inclusion macro guard that I talked about before. And inside of this guard, then we are declaring a class called IntCell, and we have our public and our private sections. Our private section is identifying some encapsulated attributes, in this case stored value, which is meant to store the integer value that this memory cell is mocking, if you will, or abstracting out. And then we have the declaration of our constructor on line 10. Again, we're making use of the word explicit because we have the potential for a single parameter constructor here. That single parameter is given a default value, so we can create instances of an IntCell with 0 or 1 arguments. In the case that it's with 0 arguments, the initial value will be 0. And in the case where we have an argument, it'll be whatever we give it. Then we have our accessor method on line 11 declared. Again, given it's an accessor method, we use the const keyword to enforce the semantics behind an accessor. And then we have our mutator method on line 12 declared here, read and write operations, if you will. And write is simply going to take a value x and take that value and store it in initial value, or store it rather in stored value. Let's take a look at the implementation details. So in figure 1.8.cpp, first thing we do is pound include that header file. That gives us the declaration to work with. And now what we're going to do is simply define all those methods that were declared within the class. Again, they're also referred to as member functions. So as we write their definitions, we're going to make use of the class name, IntCell, and the scope resolution operator, 2 colons in a row, followed by the method that we are implementing, i.e. the function that is a member of this IntCell class. So we begin with a constructor. Again, there's no return type on here, so it's just the class, members, or the scope resolution operator, and then the constructor name. And notice in the definition we are not including the initial value. All right, the initial value, or default value, I should say, is supplied in the declaration. We do not supply that in the definition. All right, we just have this parameter. Secondly, we're going to make use of this what's called an initialization list, which is basically the colon following the parameter list for the constructor, and then any of the attributes that are going to be initialized in this list. This would be a comma-separated list of attributes if we had more than one attribute. And we're using the standard initialization syntax, these curly braces, following the attribute name and giving it the argument that was passed in. Similarly, we have our read and write operations. The read operation returns an integer, so there's our return value. It's a method or a function or member function. It's a member of the IntCell, so we have the IntCell followed by the scope resolution operator, basically saying that this read method, this read function is a member of the IntCell class. And then finally the const keyword used to designate that this is a accessor method, and as such should not be changing the state. All we're doing is accessing the value of stored value, so we're not changing the state, so that's good. And then we have our mutator, write method, again, it's a member of the IntCell class. It doesn't have a return type. It's specified as void. It has a single argument, and that argument is being assigned to the stored value. And then finally we have figure 1-9, which shows how we could use such a class. Now in this case, we are going to print some statements to the standard output, so we need to pound include IO stream. And then we're going to declare an instance of the IntCell, so we need to pound include where that thing is declared, and that was declared in figure 1-7.h. This then allows us to declare M as an IntCell. This is making use of the default constructor. Then we call on the mutator. We're sending a write message to the object named M, and we're basically writing the value 5 into the IntCell. And then we're printing the contents of that cell by sending the read message to the M object, and that is accessing the value of stored value, and then we return 0. Now this is a program that involves a couple of files, right? We have the definition of main, and then we have the definition of an IntCell located in figure 1-8.cpp. So when we go to compile this, we're going to have to do a compilation that involves a couple of files. So let's take a look at how that might be done. So let's get into the appropriate directory, and that is located not here, but rather in our lectures folder. Sorry, I'm trying to multitask here. In our source directory in the Weiss folder, and there's all these files. So if I wanted to compile this, I would say figure 1 dash, what was it, 8? 1-9 is what contains main, and we're making use of the IntCell class, which is defined in figure 1-8. So we need to include that. Again, we don't specify the header files here. We'll change that when we work with class templates, but for now we're not working with class templates, so we specify these implementation files, and we should be good to go. Now, since I didn't use the -o switch to indicate or name the executable, I just have a.out, and if I run this, it should show me exactly what I expect here. So there you go. This is our basic separation of interface and implementation with our IntCell.